Okay, we're going to skip to example 4. Example 3 is the word problem. Actually, it's kind of an easy word problem. All you have to do is type in, I would look at this in your book, page 447. Just type in the equation into the calculator, and all you have to do is type in, all you actually have to do is look at the table or use the trace key to find out um, the answer to it. So it's not a hard problem. That's not why I'm skipping it. I'm just saving some time here. But take a look at page 447. We're going to go to example 4. We're going to graph something that looks like this. So that's why you have to know this. Y equals a square root of x minus h plus k. Alright, so tell me a few things here. This a is -2. What does that tell you? Since it's negative, it tells you it's a reflection. So if I'm going to draw a rough sketch of this, right? This is a square root function. So the original parent was y equals square root of x. Okay? That parent was like this. Looks like that. Since that's a negative, it would be down here, right? That's a reflection. Since that's a 2, you would say, by comparison, it would be a vertical stretch. So it would be bigger. Everybody following me here? Since it's negative, it's down. Since it's 2, it would be stretched out more than the parent right here. So it would look like, I'll just draw a rough sketch here. So far as that. But then you have this and this. Your H and your K. Alright, so all H and K do is move it. It's a translation. Okay, it's translated. So here's what you have to remember out of this. It translates H units horizontally or horizontally. Okay, meaning left to right. So this will change things left to right, and this K will always translate up or down. So translates H unit horizontally, left and right. I'll write that left or right, and K units vertically. So up or down. Okay? So basically, this 3, it's x minus h, so h is a positive 3. Okay? Don't think it's -3 because this minus, it's positive 3. So actually, this whole thing would move 3 units to the right. So let's write that. This graph in particular moves 3 units to the right. And if you look at the k is +2. So it also moves 2 units up or down. Should move it up. So all this thing would do is it flipped down because of the negative. Since that's a 2, it made it stretch. And these two numbers will translate it 3 to the right and 2 units up. So I'm going to take every coordinate on this thing right here and move them 1, 2, 3 to the right and 2 up. 1, 2. So this thing is going to be up here and down this way. Okay? So let's look at it over here. The normal one is this. Okay? That's the parent. This one, which is the problem I was just working on, is first off you have to graph y equals -2 root x, and then you just translate this and this. So -2 root x, so I'll put that in green. Okay, so it'd still be 0, 0. If I put 0 in there, you get 0. If I put 1 in here, you'd get -2 times 1, which is 1, -2. Put 1 more in here. Let's put 4 in here. So square root of 4 is 2. So negative 2 times 2 is negative 4. So I put 4 in, and I got negative 4. So it would look like, right now, it's going to look something like this. Okay? But I still need to do this and this. I need to translate it 3 units to the right, 2 units up. So I'm going to do that in purple. I take every coordinate that I just plotted, could be all of these, and just move them 3 to the right. I'm going to take this one, 1, 2, 3 to the right, 2 units up, 1, 2, put it right here, make a dot. Take this one, 1, 2, 3 units right, 2 up. Take this one, 1, 2, 3 to the right, 2 up. There it is. I'm going to draw myself my curve. And this is the graph of this thing right here, the purple. Why do I need to know that? Because the question says find the domain and find the range, the hard part. The first question we did today with domain and range was the easy ones. This, because it's complicated up here with the H's and K's and the A's, now you have to really understand. Not a little bit understand. Here we go. Alright, so as you notice, it starts here. So I'm going to actually put this final product right here. Let's see. 1, 2, 3. Down 2 over 2. Okay, something like this. Okay? It's just a shorter version. Okay? Now, what's the domain of this? What's the range? Actually, let's do the easy part. Let's do the range. Range is all the y's, right? Look where it starts. It starts right there. And it goes up or down. It goes down. So the y values go down. So that's, we'll say, less than or equal to. Because it's going down, it's less than. All you got to do is put one number here. Where does it start? It starts right here. What value is this? Well, that coordinate is 1, 2, 3, 2, 3, comma 2. Where does it start? Well, we're only talking about y value, so that's why it's 2. Okay? So basically this, here's the trick to finding the range of a square root function. It only deals with the k value. Okay? How do I know it's going down? Negative. So since it's negative, it's going down. Since it's 2, it's starting at 2 and going down. So that's why I said y is less than or equal to 2. Now domain is a little bit trickier. Domain is what could the x be. So here's the deal. Let's rewrite it. Y equals negative 2, x minus 3 plus 2. Look at that x. What could x be? Well, here's where you have to do a little bit more algebra. If I erase this right here, what could be underneath the radical? Could it be positive? Yes. Could it be negative? No. You can't have the square root of a negative number underneath here. So here's what you have to do. To find domain, make a note of this because you won't remember. Find domain, set the quantity under the radical, which is what in this case? It's all of this right here. It's all of it. Here's the quantity underneath the radical. Set that quantity under the radical to be greater or equal to 0. Write that note down. Remember this note right here. This only is for square root functions. This is not for cube root functions, only for square root. Okay? So all I'm going to do off to the side is say, okay, x minus 3, whatever's underneath here has to be greater or equal to 0, right? Whatever's underneath here. So solve this thing. Plus 3, plus 3. So what does that mean? X has to be greater or equal to 3. There you go, you got your domain. Domain, x is greater or equal to 3. Doesn't that make sense? Look at the picture. It starts here and it goes to the right, right? If I'm looking left and right, it starts here goes to the right. It starts at 3 and it goes to 4 to 5 to 6 to 7. That's why it's x is greater or equal to 3. All you have to do is set whatever's underneath here greater than or equal to 0, and you got your domain. Okay? That's the trick. Remember that trick. How do you find the range? All you gotta do is say, okay, it starts here and it goes down. So starts at 2 and it keeps going down. Less than or equal to 2. There's the trick to find domain and range. Okay? So recap. How do you find square root function, domain, range? Basically, you look at the k. K deals with the range. So since it's negative, it goes down, right? It starts here and it goes down. So therefore, y is less than or equal to whatever the k is, 2. What if that was a positive 2? That would mean it would be going up. So you'd have y is greater than or equal to 2 if that was true. Here's your range. How do you find domain again? Recap. Whatever is underneath this radical, which is this, set it greater or equal to 0, and which means it doesn't seem hard, but people have trouble with this kind of stuff. Here's your domain. Okay, domain, range, there you go. Know how to graph. You can do that right in your calculator, graph some points to help you out. But don't rely on your calculator because it's hard to tell. You can't tell from your calculator what the domain and range are sometimes. Sometimes you can, a lot of times you can't. Don't rely on it. Just think, okay, what does my K mean? What does my H mean? Let it help you out a little bit. Okay? And actually, H deals with the domain as well. H has to be greater or equal to 3. Okay? The range deals with this, the K. There you go. Last example here. Here we go. Example 5, last one in this section, deals with cube roots. Where is my cursor? Alright. Last example, cube root functions. We're going to graph this right here, and then we're going to say domain and range, domain and range. Now here's the deal. I'll just tell you right away. Since it's a cube root, it doesn't matter what's underneath this radical. You do not have to say what's underneath the radical is greater or equal to 0. That's not true. This underneath here could be anything. Positive, negative. You could have the cube root of a negative, positive, 0, whatever. So here's the deal. The domain of all cube root functions is all real numbers. There's some easy points. The range of all cube root functions. Now remember what they look like. They look like an S, whether it be this S or this S. It keeps going up and it keeps going down. So that means all the Y values are covered because it goes up and it goes down. So the range is everything. Range is all real numbers. That's the easy part. Okay? So the graphing part, really, you can type that in your calculator, and that also translates this H and K. What is H in this case? H is equal to negative 4, right? Because it's x minus h. So H is negative 4, and K equals, this is negative 1. So this graph would translate negative 4 in the H direction, which is the x direction. So pretend to move this to the left 4, and K means up and down, so move it down 1. So it would, maybe look like it moved 4 places this way, so, and then it moved down 1. So maybe something like, okay, it would move left 4, down 1. That's just a rough sketch, okay? So, but it also, what would that 3 do out front? That 3 is the A value, right? Would that be a vertical stretch or a vertical shrink? It would stretch it out. That's why I drew this a little bit bigger than this one right here. So I made it up higher and down lower. Vertical stretch. But that's not what the question asked for. It just said, what's the domain what's the range, and how to graph it. Okay? Get some coordinates from your calculator for the graph. Alright, that's how you deal with a cube root function. So understand how to do a square root function. That's the most complicated one because it's not this. All real numbers, all real numbers. You have to work it out. Okay? So go over that until you get it. Do some practice problems. Alright, let me do this word problem real fast. Basically, it's a calculator problem. So, it said the period of a pendulum is, time a pendulum takes one back and forth swing. The period t in seconds can be modeled by this function. So, remember seconds here, 1.11 times square root of L, which is, L is the pendulum length. So, here's length, here's time. It says, basically put this in your calculator. So y equals 1.11 square root of x. Put that in your calculator. How long is the pendulum with a period of 3 seconds? So what are they giving you? Period, 3 seconds. That is the t or the y. So they're telling you this is 3. Okay? So you don't want to use your table for this. You won't get exactly 3 for y in your table, so you can use what they tell you to use is the trace button. Okay, so let's go to solution over here. So this is what you would see. Well, if you change your window up, this is what you would see. And they tell you to use the trace feature on your calculator and look for when y is equal to 3. So just take this cursor and trace it until you get to about y equals 3, and they got an answer of x is 7.31. So about 7.3. What does that 7.3 represent for x? This is a word problem, so you check it out. And 7.3 feet long, period, 3 seconds. So that's how you do that word problem. Just basically type in the calculator using the trace button.